Okay, day 9, last day of vectors, some heavy-duty applications, things we've done before, but we should have a pretty good plan of attack. Finding the resultants are oftentimes what we're doing, which means we've got to create two vectors, both in component form, then take their sums, finding their magnitude, and then direction. All right, so we're going to start with a plane heading north 10 east at a magnitude of 410 miles per hour. I got that. 410 is the magnitude, the velocity. The angle is 10 to the east of due north. We now are pretty good at that. North 10 east is 90 minus 10, or an 80-degree math angle. So the component form of that vector is 410 cosine of 80, comma 410 sine of 80. Wind vector, 70 in a direction of south 50 east. We're going fourth quadrant, pardon me. Again, I'll try to draw it to scale. That's a 50. That's a 50. 50 degrees in the southeast direction is 270 plus 50, which the magnitude and direction of this vector is 50 cosine of 320, 50 sine of 320. Vector red, the plane in component form, 71.2, 403.8. Vector blue, the wind, fourth quadrant vector, better be a positive negative, 53.6, comma, negative 45.0, which it is. What's the resultant? We could draw into green if we wanted to, but we know that vector green is just the sum of vector red, which we'll call the plane vector P, plus the wind vector W. Get away from those U's and V's. And if we add red and blue, we get 124.8, comma, 358.8. And we want to find the actual ground speed, which we know to mean the magnitude of the resultant. Square root of 124.8 squared plus 358.8 squared. We're going 380 miles per hour. That wind blowing against us takes that 410 and drops it down about 30 miles per hour. All right, the actual heading of the plane, moving it off course, we're going to find theta of that resultant, tan inverse of 358.8 divided by 124.8, which gives us a math angle of 70.8. That's in the first quadrant. We're going to subtract from 90, 19.2. So we have a north 19.2 degree east angle. If you want to DMS it to be even more accurate, you could take that decimal 0.2, becomes a 19 degrees 11 minutes northeast. Really great orienteering question. If we want to actually compensate for that vector, which visually means we're really going to aim more to the north to offset the wind, maybe up here somewhere. But how much? Well, the answer is we're going to take that wind vector, which we had to be blue, and just negate it. So now blue compensated is negative 53.6, comma, positive 45.0. And we're just going to simply add that to the initial vector red to get that green vector. That's not the path we'd actually take, so we don't want the magnitude. We just want its heading. What heading does the pilot have to take to compensate for the wind and not end up in Lake Michigan? Well, we're going to take that vector red, which we know to be 71.2, 403.8, and add to it vector negative W, negative 53.6, 45.0. So this compensation vector, I'm going to write it in black, R2, equals 71 minus 53, 17.6. 403 minus 45, or pardon me, plus 45, 448.8. And again, I don't want the magnitude, but I do want direction. Tan inverse of 448.8 over 17.6 equals 87.8. Again, subtracted from 90. That's a 2.2. So I'd have to head, or the pilot would have to head on a north 2.2 east, or again, if we DMS it, north 2 degrees, 15 minutes east, heading more to the north to offset that southeasterly wind and get back on course. Great question, very real, probably what air traffic controllers and pilots do all the time. All right, let's move on to another question. Let's try to get 3 in today, and we'll call it a unit. We'll jump ahead on this one. Let's take a nice easy force vectors. And then we'll do one more navigation. Force vectors of magnitude of 20 and 10 newtons act upon an object such that the resultant force is 25 newtons. A little different. We're going to see what tools in our toolbox are available. So we're going to put this 20 at 0. We're going to put this 10 up here. And we know the resultant is 25. Well, we actually know a couple things. Number one, the vectors aren't exactly opposite each other, otherwise we'd get the difference, which is 10. They're not exactly head to tail, because we'd get 30. Somewhere in the middle, 25. But there is no angle, there is no way to create component form vectors, so we're actually going to use one of our trig laws. And what did we use for side, side, side? Remember, we can copy this 10 over to here. Oh yeah, we use law of cosines. And since I'm looking for this angle right here, I'd have to find both the bottom and the top, or I can find this angle as my unknown, and the relationship between any two, good geometry rule, any two consecutive angles of a parallelogram is their complementary. So actually, after I find this green theta, I'm going to take the complement to get this blue angle between the two force vectors that we're looking for. Pulling back an old tool, we're going to find theta by saying 25 squared equals 20 squared plus 10 squared minus 2 times 20 times 10 times cosine of I don't know, theta. 625 equals 20 squared plus 10 squared is 500 minus 400 cosine theta. Don't forget your good operation work here. Subtract the 500 first. Then we're going to divide off that negative 400. Theta equals cosine inverse. So that theta is 108 degrees. But remember, we want the blue, and the blue theta is 180 minus 108, which is 72 degrees. That's the angle between those two forces. Again, vectors are great. I love component forms. I think they're really easy. But once in a while, you get a question like this that it just doesn't fit. That's why you have to be really good at using the law of sines, law of cosines if you need to as well. All right, one last question. Here we go. Let's buckle up. One more navigator. Okay, what do we got? Plane traveling 400 miles per hour and a heading of north 48 east. Easy for me to say. North 48 east. First quadrant, 48, 90 minus 48. That's a 42 degree angle. Then we have the wind blowing. That should be 82 mph, sorry. north 20 west. That's 90 plus 20, which is 110 degrees. So we're going to draw our vector red, magnitude of 410, heading 410, cosine of 42, 410, sine of 42. Let's get in component form while we have it. 304.7, 274.3. Gotta love this stuff. Now we can draw our magnitude and direction of our wind vector. We said it's 82 miles per hour. Try to draw it to scale. The angle we said we're going to use is 110, 82 cosine of 110, 82 sine of 110. In component form, second quadrant better be negative x, negative 28.0, 77.1. I now want to find the resultant, which we've done a lot now. Resultant equals plane plus wind, x plus x, y plus y. The resultant's component form, 276.7, comma, 351.4. Ground speed is magnitude of resultant. Square root 276.7 squared plus 351.4 squared. When all said and done, 447 miles per hour. The wind actually did speed us up a little bit, more of a tailwind than a headwind. Direction, what heading does the plane have to take to stay on course? We're not going to add, let's call this R2, which we'll do in black. We'll do P minus W. Which gives us 332.7, 197.2. Again, we didn't want the direction of the first vector, r, in green. We don't want the magnitude of the black vector, r. We're just going to take its direction because that's the compensation to be on course, not off course. We got tan inverse of 197.2 over 332.7. We get 30.7. But again, we got to subtract that from 90. Final angle, north, 59.3 degrees. East, otherwise known DMS, if we said nearest minute, 59 degrees, 21 minutes. East is what they have to aim to make sure they're back on course. Where that would put us is, we'd be up here a little bit more on that illustration. All right, sounds good. We got about 1 minute left. Great work, great unit. Really like vectors. I know it's slightly different than what you might do in physics, but this component form is really powerful, not to mention the laws that we learned, something that you want to be really good at. Take a look at these. They're also on the work packet as well and the work sessions. And we're going to set up, hopefully through this time, some hours to do some office hours that you guys can reach out to Mr. Ducharme and or I directly. And especially be safe, be well, and we'll see you all back in school soon.